Good morning, guys. Today we are going to discuss equations. It will start first with first degree equations in one variable. So, an equation is a statement that two mathematical expressions are equal. For example, 3 plus 5 equals 8 is an equation. So, most equations that we study in algebra contain variables, which are symbols, usually letters, that stand for numbers. In the equation 4x plus 7 equals 19, the letter x is the variable. We think of x as the unknown in the equation. And our goal is to find the value of x that makes the equation true. The values of the unknown that make the equation true are called the solutions or roots of the equation. And the process of finding the solution is called solving the equation. Two equations with exactly the same solutions are called equivalent equations. To solve an equation, we try to find a simpler equivalent equation in which the variable stands alone on one side of the equal sign. Here are the properties that we use to solve an equation. So in these properties, A, B, and C stand for the algebraic expressions, and the symbol, the double-headed arrow, it means is equivalent to. So these are the properties of equality. So number one, we have A equals B. It means that is equivalent to A plus C equals B plus C. So adding the same quantity to both sides of an equation gives an equivalent equation. As you can see in the property number one, so what we added in the left hand side and the right hand side are of the same variable or a letter C. So therefore, these two equations, A plus C equals B plus C, is just the same as A equals B. Number two, A equals B, it means that is equivalent to CA equals CB, where C is not equal to 0. It means to say that we are multiplying both sides of an equation by the same non-zero quantity gives an equivalent equation. So let's define first linear equation. A linear equation is one variable is an equation equivalent to one of the form ax plus b is equal to 0, where a and b are real numbers and x is the variable. Here are some examples that illustrate the difference between linear and non-linear equations. So in this column, we have linear equations, and the second column is for non-linear equations. So when we see linear equations, here are the examples. We have 4x minus 5 equals 3, 2x equals 1 half of x minus 7, and the third example is x minus 6 equals x over 3. And for the next column, we have non-linear equations. We have number one, x squared plus 2x equals 8. Square root of x minus 6x equals 0. 3 over x minus 2x equals 1. It says here on this equation, this is not linear. The example of x squared plus 2x equals 8 is not linear because it contains the square of the variable. Okay, comparing this example to the left side, which is now 4x minus 5 equals 3. So the first one, 4x minus 5 equals 3, is a linear equation because it contains the highest degree, that is 1. If the highest power or degree of the equation is 1, then it is linear equations. And in this second example, under the nonlinear equations, we have the square root of x minus 6x equals 0. This is also not linear because it contains the square root of the variable. The square root of x minus 6x equal to 0, the first term, which is the square root of x, can also be written as x raised to 1 half. Since the exponent there is not 1, all right, and that is in the form of 1 half. Therefore, it is non-linear. as I have said earlier, the linear equations with the first degree as the highest exponent, then it is known as linear equations. What about on the third example? We have 3 over x minus 2x equals 1. This is not linear because it contains the reciprocal of the variable. We can have a reciprocal but should be only in the constant but not the variable itself, because 3 over x can be written as 3x to the power of negative 1. The 3 over x can be written as 3x to the power of negative 1, and it's because of that it becomes a non-linear equations. Now on the third example here, in the linear equations, we have x minus 6 equals x over 3. Take note, x over 3 there, we have a coefficient of 1/3 to this x. Therefore, the highest exponent there is still 1. All right? So therefore, this example is a linear equations, while this one, if the variable is in the denominator, then it is not linear. So let's try to solve some exercises or examples in solving linear equations. So I have 7x minus 4 equals 3x plus 8. Since it's not your first time to undergo or experience solving equations, I'm just going to solve this in a short method. All right? So what I'm going to do is to combine like terms in one side. So by combining that one, so combining the x, and we'll write that one in the left hand side. So I can write now as 7x. When you transpose, always change the sign. When you transpose 3x to the left side, and negative 4 will be transposed on the other side, on the right hand side, always change your sign. Therefore, it becomes 7x. Since we transpose 3x to the left, it becomes now negative 3x equals 8. And negative 4 will be transposed to the other side, then it becomes positive 4. So combining like terms now, we have 7x minus 3x is 4x is equal to 8 plus 4 equals 12. Then we want to solve for x, but there is a coefficient. So in the variable x has a coefficient, then you have to divide both sides by that coefficient. So I will write here 4x over 4. So I'm dividing both sides by 4, and this will be cancelled. 4x divided by 4, we have x. So therefore, the final answer now become x is equal to 12 over 4 means 3. So therefore, x there is 3. Now, if you're going to substitute the value of x to the original equation, then it will give you a true value. When I say true value, the left-hand side will be equal to the right-hand side. Okay, now let's move on to example number 2. Solve for the variable m in the equation. So this kind of equation is what I call as solving literal equations, wherein this is very useful in other subjects such as chemistry and in physics. So we are going to solve first the variable that is required to be solved before you're going to substitute the given. That is how are we going to solve in chemistry and in physics. Now I'm going to solve now for the variable of the uppercase m. I'm going to highlight this one. I want to solve the variable uppercase of m. So first of all, I'm going to cross multiply the f and the denominator on the right hand side. So I can cross multiply that one because there's only one term in the right hand side. So multiplying that one, it becomes now fr squared. So we have fr squared is equal to g m in the uppercase m. So we want to solve for m, but I have a coefficient of g and m. Therefore, I'm going to divide both sides by g and m. So we have gm. So this one will be cancelled now. So therefore, m is equal to fr squared over gm. So this is now the answer for that example. So next we have to solve 5x minus 13 equals negative x plus 5. It's almost similar to the first example. So in that case, we are going to transpose. The purpose of transposing is to combine like terms. So I have now 5x. The negative x will be transposed on the left-hand side, becomes now positive x. And then negative 13 will be transposed to the right-hand side. Then it becomes now 5 plus 13. When we transpose, we change the sign. Therefore, it becomes 5 plus 13. So combining like terms now, we have 5x plus x. We have 6x equals 5 plus 13 equals 18. And then, since we have the coefficient of x, we divide both sides by 6. Therefore, x now is equal to 18 over 6. That is now the quotient equals 3. All right, so next example, we have 2x plus 5 times the quantity of 6 minus 3x equals 7 minus 4x. In this case, we are going to use distributive property first. So I'm going to write now 2x plus, using distributive property, we have now 5 times 6 is 30. 5 times negative 3x is negative 15x equals 7 minus 4x. Then after that, transpose to combine like terms. I have 2x minus 15x. I have another x here on the right-hand side. We have negative 4x. It becomes now positive 4x equals 7. Transpose positive 30 to the right-hand side becomes negative 30. So we have 2 plus 4 equals 6x minus 15. So what is now the answer? So the answer here becomes negative 9x equals negative 7 minus 30 is negative 23. Now divide both sides by negative 9 because we want our x to always be positive. We don't solve for negative x. We solve always as positive x. Therefore, we divide both sides by negative 9. So the answer now will be, we have negative 9x divided by negative 9 is x is equal to negative 23 divided by negative 9. The quotient now is just a fraction form. So we will just write there 23 over 9. We can express our answer in terms of fraction form instead of a decimal number. Okay, next we have here. So we still, in this example, we're going to use distributive property on the first term. So I have now 2 times 5 equals 10. 2 times negative 4x is negative 8x plus 3x equals 7x minus 14. So combining all the x, we have now negative x and 3x is negative 5x plus 10 equals 7x minus 14. Or you can do it directly. You transpose the 7x to the left-hand side, like what I did on the previous example. Or you can do like this first. So we have now negative 5x minus 7x equals negative 14 minus 10. Because from positive, we transpose becomes negative 10. And then combining now the like terms, we have now negative 12x equals negative 24. But we have a coefficient of x that's negative, so therefore we divide both sides by negative 12. Dividing this by negative 12, therefore the value of x now is equal to positive 2 or just 2. Okay, for the next item, we have here 5 minus 3 times x minus 6 plus 3 equals 3 minus 2 times the quantity of x plus 4 minus quantity of x minus 30 plus 1. So let us try to reduce first each side. So using distributive property, I can combine now 5 plus 3 equals 8 minus 3 times x, negative 3x. Negative 3 times negative 6 is positive 18. I will not write anymore 3 because I combined already 5 and 3 equals, I have here 3 plus 1 equals 4. Then this one we will be using distributive property. As well as this, we're gonna use distributive property. So we can have negative 2 times x plus 4 equals negative 2x. Negative 2 times 4 is negative 8. And this one, we have just changed the sign because the sign is negative. So we have negative x, positive 30. No need to write 1 because I already added 3 and 1. Now, I try to reduce again the terms and on each side. So by combining like terms first, I have 8 plus 18 is 26 minus 3x equals, we have negative 2x and negative x is negative 3x. So 4 minus 8 is negative 4. And negative 4 plus 30 is positive 26. Okay, so I have now two terms on both sides. Now I'm going to transpose to combine like terms. So I have here 26 minus 26 is equal to negative 3x. The other one with positive 3x. So this one is 0 and this is also 0. So we need to say we don't have the value of x. Okay, for this example, we have 2x over x minus 2 plus 3 equals 4 over x minus 2. We are going to eliminate first the denominator. If we have this kind of example, always eliminate first the denominator by multiplying its LCD. So the LCD there, or the less common denominator, is x minus 2. Then I'm going to multiply the entire equation by x minus 2. So multiplying this, the entire equation by x minus 2. So actually, we're multiplying both sides of the equation. So to make it short, I will just use the bracket, then multiply this by x minus 2. X minus 2 divided by x minus 2 is 1 times the numerator, that is now 2x, plus, since there is no denominator here, just a whole number, then multiply right away 3 times x minus 2. So I will just write it first that we are showing that we are multiplying the 3 times x minus 2 is equal to, this one is x minus 2 divided by x minus 2 is 1 times the numerator is 4. So all we need to do now is to simplify this second term. So we have 2x plus, this using distributive property, we have 3x minus 6 equals 4. And combining like term to reduce this term, I have now 5x minus 6 equals 4. And then transpose negative 6 to combine with a constant term as well. So therefore, 5x equals 4 minus 6 become plus 6. So therefore, 4 plus 6 equals 10. And divide both sides by 5. So therefore, dividing both sides by 5, we have now x equals 2. So next we have here, the surface area of the closed rectangular box can be calculated from the length L, the width W, and the height H according to the formula of A equals 2LW plus 2WH plus 2LH. That is the formula for the rectangular box. We are asked to solve for W in terms of the other variables in this equation. So we are trying to solve W, but I have also W in the other term. So first, what I'm gonna do is that I'm going to transpose the third term on the left hand side, since this is the only term that has no variable W. So I can write now as A minus 2LH is equal to 2LW plus 2WH. Take note, we want to solve for W. Then in order for that to be isolated, I will factor out first the common W on the right-hand side. But of course, I'm going to rewrite on the left-hand side, we have A minus 2LH is equal to W is a common factor. Then we divide. We have 2LW divided by W is 2L plus 2WH divided by W is 2H, right? Now, we can easily solve now for W. So, we have W times 2L plus 2H, wherein this quantity is the coefficient of W. So, it is now easier to eliminate this quantity. Now, I'm going to divide both sides by this quantity of 2L plus 2H in order for us to eliminate for that. So, over 2L plus 2H also on the other side. So this one now will be canceled. So we have now W. I will just write W in the left hand side. So W is equal to A minus 2LH over 2L plus 2H. So that's the answer for that.